Good day, students. Today, we want to consider a topic titled Free Energy and Free Energy Change. We have different forms of energy, which are chemical, mechanical, light, radiation energy, and several of them, in which the energies are interconvertible. When you convert from mechanical energy, light energy, chemical energy, and other form of energy to heat energy, the conversion is total, completely total. But when you are converting from heat energy back to other forms of energy, it is not total. Is that okay? It is partially converted. Is that okay? Now, let's now understand that when we are using heat energy to carry out some work, part of it are used to carry out the work, while others are not useful. The one that is useful in carrying out the work is referred to as free energy, while the one that is not used in carrying out the work, we use entropy change to explain that. Okay, we use entropy. It's a measure of the unavailable energy. Now let's see what's on the board. There are different forms of energy, such as heat, chemical, mechanical, light, and radiation energies. Energies is interconvertible. The different forms of energy can be completely converted to heat energy, whereas when the heat energy is converted to any of the other forms of energy, the conversion is not total, because there will be heat loss to the surrounding because of converting it from mechanical, light, radiation energy to the heat energy. There will be loss of heat, and when you are converting it back, not all the heat has been lost that will be converted back, because some have been lost. Is that okay? To the surrounding. Okay. Now, consequently, when heat energy is used to perform work, part of it will be available to do the useful work, and the remaining part will be unavailable for useful work because it has been lost to the surrounding. You can see where they have heavy equipment, where mechanical process are taking place. You see there will be heat in any machine that is rubbing each other in the course of carrying out a production. Heat is being lost that cannot be used in carrying out the work, and the one that is lost is the measure of the unavailable energy, which is the entropy. We use entropy to measure the unavailable energy that is not used to carry out the work. But the one that is being used, the energy, this energy that is being used to carry out the work, is referred to as the free energy. Is that okay? Now let's see. The portion of the energy, heat energy, which is readily available for useful work, is referred to as the free energy of the system. Entropy is a measure of unavailable energy. Take note, unavailable energy. We use entropy as the measure of it. When entropy is multiplied by absolute temperature, the product Ts is equal to the amount of heat energy which is not free to be used for useful work. Okay, now if the total heat content of the system is defined as H, and the total heat content of the system is defined as H, and the free energy as G, then G equals H minus Ts. This is the total heat content, that's the enthalpy, minus absolute temperature multiplied by the entropy. Is that okay? Now, where G is the free energy, that is the heat energy available for useful work, H is the enthalpy, that is the total heat content. T is absolute temperature, S is the entropy of the system. Now, let's see, delta G degree equals delta H degree minus T delta S. The standard free energy chain is made up of energy factor. The standard free energy chain, which is this, It's made of energy factor delta H degree and an entropy factor delta L degree, both of which have been used before to predict the spontaneity of the reaction. Both of them have been used. They were both found to be inadequate parameters when used separately. When you use them separately, they are inadequate parameters. The free energy chain, which combines these parameters for predicting the feasibility or spontaneity of a chemical reaction. We talk about spontaneous. When a reaction is spontaneous, it means that the process is being carried out on its own accord. It takes place, for example, when you put an ice block in the container, you see that it starts melting, gaining heat, absorbing heat. That is an endothermic reaction, absorbing heat. It happens on its own accord. The melting takes place without applying any external factor of heating the ice block before it melts. That is spontaneous reaction. That's what you are seeing. And also when you see the cloud forming during sunny period, forming together, it happens on its own accord. That's natural occurrence of spontaneous reaction. Okay, let's see. For a spontaneous reaction, the value of delta G degree must be negative. That is, the free energy change must be negative. Before when you are calculating free energy change in your calculation, we have to look for the free energy change. When you get the value as negative, that means that it is spontaneous. Take notes. When the value of delta G, the free energy change, is positive, it means the reaction is not spontaneous in the direction written. If delta G, the free energy change, is 0, the system is at equilibrium. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.